Hey, good afternoon, everyone. This is me, Celso Batalha, and Friday, and I'm about to start correcting your exam. And I'd like to outline solutions to the problems, and so then you can start working on it. At least review and have a better idea of what what happened. Anyway, so we have a soccer player kicks a ball, giving an initial velocity of 9.0 meters per second. Now in a positive x direction, so we have only one axis, x direction, positive to the right, and then you have a ball that is kicked with an initial velocity of 9 meters per second. Because of the wet grass and dirt, the ball slows uniformly to 3 meters per second. So which means when it gets to the speed of 3 meters per second, and I'm calling this final velocity, it has traveled. So the ball is here and now has a speed that is 3 meters per second, and then it has traveled 30 meters. So a distance that has covered this 30 meters. What is the acceleration? So we want to solve for acceleration. And then there is a hint here. Acceleration is a vector. Direction must be specified. So out of the three equations of motion we are studying, y minus y naught is equal to v naught t plus or minus half a t squared. The other one is v is equal to v naught plus or minus a t, depending on if you have acceleration or deceleration process. And the third one is Bernoulli, that combine those two data into one single equation. So based on the fact that we have initial velocity, we have final velocity, we have del x, and we want to solve for acceleration, this equation here seems to be the best one to use. And that's what we do. So 3 squared is equal 9 squared plus 2a times 30. And then acceleration is equal 9 minus 81, which is 9 squared, right? Divided by 2 times 30 meters per square second. Then you calculate that. A cheetah can accelerate from rest to a speed of, so from rest, initial velocity 0 meters per second to a speed of 30 meters per second. That's our final velocity, 30 meters per second, in a time that is 7 seconds. What is the acceleration? So solve for acceleration. Well, out of the three equations we are studying, it seems the one that relates velocity and acceleration and time are the best one. And that's what we're going to do. So 30 is equal to 0 plus a times 7. Acceleration is 30 divided by 7 meters per square second. An object is dropped from a height of 75 meters above the ground level. So let's say you have a cliff or something. This is your 0 point, and that's your high point. So it's dropped from there 75 meters, right? So it's dropped. This word here, dropped, means Initial velocity is 0. It's dropped. You're not throwing down, right? It's dropped. Determine the distance traveled during the first second. So distance x, or in fact y. So you want a distance on the first second. So how do we do that? So the object falls down, time equals 0 is up there, right? So it then falls and it gets here 1 second later. Time is equal 1 second. And we want to know how, the absolute, what is the distance the object cover here? So in the first second. So the equation we have of motion that relates distance with time is y minus y naught is equal to v naught t. Now, this is a problem that involves free fall. In free fall, the acceleration has a constant value of 9.8 meters per square second. So v naught minus, because the acceleration has a constant and fixed value given by that. So the next thing we do is to say this is y, this is your y naught, right? So y minus y naught is negative of the height, so negative of 4.9 t squared. The time considered is 1 second, so we are talking about 4.9 meters in the first second. So the term the final velocity at which the object hits the ground. So the object goes down 75 meters. We have the acceleration. We can perhaps get by with Bernoulli. V final squared, that's what we want to solve for. We want to solve for final velocity, right? So final velocity squared is equal to initial velocity squared minus 2 times 9.8. Acceleration is negative times final position minus initial position. And that is final is 0 and initial is 75. So this negative sign over here cancels with the sign. So the final velocity squared is equal to 2 times 9.8 times 7.5. And therefore, we can find our final velocity as being the square root of all of that. So determine the distance traveled during the last second of motion before hitting the ground. During the last second. This is a tricky one. I think I will be lenient in the way you solve this problem. Because in the last second, so let's say the last second is here. That's crashing point. The time is 1 second here, and that is the last second. So we want to find basically this distance over here, right? What is this height over there? Call it h prime or so. So how do we figure that? Well, there are different ways of approaching this. The way I'm seeing now, and I haven't correct, so I don't know which other solution you guys might have come up with. But we could find the time taken to hit the floor, since the object is dropped, right? So because of that, and we know the height. The height is 75. So since we know the time, we subtract 1 second. And then we find the distance covered till 1 second before crashing. So if you look at my sketch here, so we know the whole thing here is 75. If we find the total time taking all the way down, so total, and we subtract 1 second, total minus 1 second, is the time it took all the way to reach this point, right? So if you know that time, we know this distance. And then we can subtract 75 from that distance to get this distance here. The distance traveled during the last second, right here. So let's do that. So what is the time that it took to, so time to hit the ground? Y minus y naught, this is 75, is equal 75 meters. In fact, it's negative 75 because the initial position is 75, right? So the final y naught, this is 0, and this is 75. So negative 75 is negative 9.8 t squared. What? I'm taping. I'll be done in a second. And then the time that takes to go all the way down, it is 75. If we cancel the negative signs here, is 75 divided by 4.9 square root of that. Okay, so the time to go all the way down, time to hit the ground, minus 1 second gives time to hit point, call this point B, I don't know why I'm calling B, point B. So what is the distance to that point? What is the distance? So this is a tough one. Perhaps some of you might find some easy way to do it. What is the distance to that point? Well, the distance is y minus y naught is equal v naught t, which is 0. V naught is 0, right? Minus half 9.8 t squared. This time over here, t squared, which is 75 divided by 4.9. And then I can find my height. So my height up to that point is equal no, I'm sorry, this is not the time. This is the time to hit the ground. So the time to hit the ground minus 1.0. So this is t squared. Square root of that, right? Where's the rubber? Where's the eraser? Minus 1 second. So that's the time that it takes to go all the way to the ground, right? So the height to the point B is equal half times 9.8 times square root of 75 divided by 4.9 minus 1 squared. And then you calculate that, right? I'm not going to do that. So the distance, so then you can solve for the distance traveled during last second is given by HB, in fact 75 is given by 75 minus HB. Okay, that's a complex problem. It has, I mean, the last part, maybe somebody can see some better solution, but that's the solution I just saw now. So basically what I did, I know the distance all the way down is 75 meters, and the distance all the way here I calculated, right? And then I subtract those two to find this much. A rescue helicopter is roving over a person whose boat has sunk. One of the rescues throw a life preserver straight down to the victim with an initial velocity of 1.36 meters per second and observes that it takes a time that is 1.4 seconds to reach the water. How high above the water was the preserver released? Well, we want to find this much here. This is what we want to find. Is equal V naught T minus, so this is a free fall type of problem, right? T squared. But here's the thing. We know the time, we know G, right? We know the acceleration. But what is the initial velocity? Well, the initial velocity is down. So when I write this number here, this is not correct. It should be negative. Negative 1.36 versus time minus 1.9, a half, 9.8 times squared. And then I can find my height. So the initial velocity, since the life preserver is throwing down, so throwing down means the velocity has the same direction as that of the acceleration, which is negative. That's why you have a negative sign here, you have a negative sign there. So once you place the time that is given, 1.4 second here, so you sub this for 1.4 second, you sub this for 1.4 second, then you can get the height. It's going to have a negative height because the final position is 0, and the initial position is weighted all the way above, and that's what you're going to find. Okay. Is it possible for a speed to be constant while acceleration is not? Yes. So if you go in circle, that's the example I gave in class. So let's say you go 3 miles per hour in a circle. The speed is the same. The speed is constant, but not the direction. The direction, which is the tangent to the path. Remember we did that in class? The tangent to the path is changing all the time. So if the velocity is changing, because velocity is a vector, is a quantity that depends on a number, but also depends on direction. The number doesn't change, but direction is changing. If direction is changing, we have an acceleration involved. And so there is an acceleration here. Okay. So in this case is an example in which speed is constant and acceleration is not. Give an example in which velocity is zero, yet acceleration is not, free fall. You throw up in the air at the highest point. At the highest point, acceleration is zero. Oh, I'm sorry. Acceleration is still 9.8, but the velocity is zero. Okay. In a subway train, is moving to the left, so that's x, 0, x. So the subway train is moving to the left, and it has a negative velocity. And then it comes to a stop. What is the direction of the acceleration? So it's slowing down. So necessarily the sign of the acceleration must oppose that of the velocity. I'm sorry, if the velocity is negative because the cart or the subway is moving towards the origin, the velocity is negative, the acceleration necessarily must be positive. So acceleration is to the right. To the right. What is the acceleration of a rock thrown straight upward on the way up? G, negative 9.8 meters per square second. At the top of the flight, G, negative 9.8 meters per square second. On the way down is the same, negative 9.8 meters per square second. Problem 9 was miswritten. Okay, this problem. Sketch a graph of velocity versus time corresponding to the graph of displacement versus time in figure below. Let's do that. So we saw in class, and this problem I took from, by the way, every time we give a midterm, I will take problems, conceptual problems, either provided by the book or book chapters or sections or at the end of the book. So this problem I took from there. So it is right here, I think. There you go. So it is in the book. I'm taking from there. I mean, I'm not going to go away from the book, right? So graph velocity versus time. So what is the velocity? Velocity is the definition of the ratio between position, the displacement, versus time. So final position minus initial position. So if you take position xb, so in this segment here AB, so let's take segment A. So A, B, C, D, C again? No, that's E. E, F, so on and so on and so on, right? And then you do these things that I'm doing now, G, and so on and so on and so on. And then you have H, I. So those are the segments. So, oh, I have K, L. I'm not going to do that. But anyway, so we are talking about velocity basically, right? It's kind of velocity versus time. So velocity in that segment AB is position in B minus position in A, the average, over the time interval. The time interval seems to be the same. It doesn't change much, primarily. So, but it's basically XA minus XB. So, as we saw in class, this average velocity, which in if we go to the point, is this instantaneous velocity, the definition of instantaneous. But the average velocity in that segment xb, xa is going to be a negative quantity because xb is less than xa. This number here, if you look at in your graphic, is less than xy, so it's a negative thing. So a and b is going to be something like this, right? And then, but at the same time, this is not a straight line. So this is average. And I'm doing here basically average, right? And the problem is asking instantaneous. Let me do average first, and then I'm gonna go to the instantaneous. So when you go to the BC, so the V at that time interval, the average is X position as C minus position as B divided by del T. Again, it is negative because XC is less than XB, but it's less negative than the previous one. It's going to be something like that. But when you go to this part, XD is bigger than XC. It's going to be a positive thing like that. And here it's going to be a positive thing, but see, the display between them is less. So it's going to be a little bit lower, right? And then you go to C and F, it's going to be a negative one. And then you keep doing that way on and on and on and on and on. But the problem asks us to do instantaneous. So when you do instantaneous, the slope of a graphic, position versus time in a given point, gives the velocity. So in other words, the speed, the velocity is negative, but keeps diminishing because the slope keeps smaller, being smaller and smaller and smaller, all the way to the part B. So when you get a C, the slope at point C is parallel to the axis, which indicates a velocity that is zero. Same thing here. The velocity is zero at these 3 points. Okay. So basically, the slope keeps diminished from point A to point B, which indicate that although negative, the speed is diminishing. So it keeps diminishing all the way to the point that eventually at point C it becomes zero, something like that. And then at points from C and D, it keeps just growing. The slope is positive, but keeps growing. See that? And then it gets to the point D where it's maximized, and it starts to, in point D, maximize, and then it starts to diminishing all the way to point C when it becomes zero again. And now the velocity becomes negative all the way to part D or G, where it's zero again. And then they start to grow and keep growing up to a maximum point. Okay, those are the answers, the key to the question. Thank you.